Hello students, today we will see a very important topic and the last topic of your syllabus, which is Doppler effect. Now what is Doppler effect? We will see the definition first and then we'll go for the expression for the apparent frequencies and different cases. Okay. So Doppler effect basically is a shift in apparent or observed frequency and not a shift in actual frequency at which the source vibrates. Okay. Now, to understand the meaning of what apparent or what actual frequency, we'll just take a simple example. Suppose this is a railway platform. Okay. A person is standing over here. Okay. So when the train is little far, okay, the train is suppose somewhere over here, just about to reach to the station, the sound produced by the whistle of the train will be heard little with a lesser frequency to the person, and when it is coming closer to him, closer to the listener, he will be able to observe the whistle to be at a very high pitch. Okay, so what we can see, as the train approaches, the sound of the whistle is heard at a high pitch, and as the train coming high pitch, and again when it passes away, the train moves away, the sound of the whistle is heard at a low pitch. So here low pitch, here again further low pitch, when it is very close, very high pitch. So this difference is basically the Doppler effect. Okay. Now, next question you'll ask me, why the Doppler effect is observed. So the reason for that is the distance between the source of sound. Now in this case, what is the source? The whistle of the train. So when the distance between the source of sound and the observer is changing, which means what? Observer is not moving, but the train is coming closer to him. When it is away, the sound is little low pitch, but when it is very close to the listener, the sound is at a very high pitch. So basic problem is the distance. Okay. So if the source and the observer are approaching, then the distance is decreasing. Source is coming over here to the listener. Distance is decreasing. And if the source and observer are receding, then the distance is increasing. Okay. The source of sound always emit the same frequency. That will not change. Only it is coming close to the listener or going far away matters most. Okay. So therefore what we can say, the same period of time, the same number of waves must fit between the source and the observer. Okay. So now again we'll try and I think now this must be clear to you that why we are trying to say the shift in apparent or observed frequency and not a shift in the actual frequency at which the source vibrates. Okay. Now we will do this with a much more clear understanding. So for that we'll go to the derivation, which is expression for apparent, as I use the word here, apparent frequency, apparent frequencies in different cases. So we'll do the derivation, very simple but very interesting also. Okay. So for that, what will I consider? I'll consider a source first. This is the source. Okay, moving with the frequency, velocity, moving with the velocity cs. This is my source. S is the source. Okay. So I took one source over here and I have a listener over here. So this is L. Okay. And this velocity over here is CL. Fine. So we have mentioned a source and a listener. Now what we say, that the sound waves are produced by the source, okay, with frequency n. So frequency is n and wavelength is lambda, obviously. Okay, wavelength is lambda. Now my next job is what? the sound wave which are produced by this source will propagate with velocity c. So I'll say over here, they are propagating with velocity c in medium m. So I'll write over here what is called as medium m, and velocity for that will be cm. Fine. So here I'll write c. So what we'll say now? The source, okay, the listener, the medium, okay, medium m, are in motion with velocities. What velocities? cs for the source, cl for the listener, and cm for the medium, okay, in the same direction. That's what I'm trying to say. So we know every letter what I'm trying to mention. Frequency is n, wavelength is lambda, s is source, velocity of source is cs, l is listener, velocity with which it is moving is cl, this is the velocity c, okay, m is the medium, okay. All these words are very clear. Now we will be in a position to go for the derivation. So what we can say first, the relation between frequency n, wavelength lambda, and velocity of sound, okay, is given by what? Basically c is equal to n lambda. So this is my c, this is my n, this is my lambda, this is my expression number 1. Okay, now what can I say? That the frequency n, this frequency n represents what? The number of waves emitted by the source per unit time. Correct? So I'll say over here, n represents number of waves emitted by the source per unit time. Correct? So therefore, what can I say? That the time interval between the emission of two successive wave, okay, two successive wave will be obviously 1 by n. Time interval between the two successive wave will be 1 by n. Now what we'll say, as this medium m, okay, as the medium is moving with the speed cm, okay, along direction of propagation of the sound, correct? So what will I say? The effective velocity of the sound will be c, which is this c plus cm. Why cm? Because cm is the velocity of this medium, okay. So as this medium is moving with speed cm along direction of propagation of the sound, so effective velocity of sound will be c plus c. This is very important. Now the distance traveled, now again very important term I am talking, the distance traveled by the first sound wave in time interval 1 by n before the emission of the second sound wave will be c plus cm divided by n. This is what? Distance traveled, okay, distance traveled by the first sound wave in time interval 1 by n before the emission of the second wave is this. Now the source is also moving, okay, the source is also moving with velocity cs along direction of propagation of sound, okay. So what we can say, the distance traveled by the source, what source? Source s, in time interval 1 by n will be how much? This will be cs by n. Moment I say 1 by n means time interval. This is time interval for the, what did I say? The distance traveled by the first sound wave in time interval 1 by n before the emission of the second sound wave is this expression. Now what did I say over here? I said that the distance traveled by the source in time interval 1 by n is cs by n. So now what I can, after getting these two expressions, I can say very confidently, therefore the effective distance traveled by the wave in time interval 1 by n with respect to source will be given by C plus Cm divided by N minus Cs by N. Now as the denominator is same, I can write C plus Cm minus Cs divided by N. Okay, I'll say suppose this is equal to lambda dash. This is my equation number 2. Fine. Now what is lambda dash? Lambda dash is the wavelength of the waves propagating through the medium. Okay, lambda is wavelength, lambda dash also is the wavelength of the waves propagating through the medium. Now the next thing what we want to learn, the velocity. Now till now we did not speak about the person sitting over here or standing over here and listening. So now we'll talk about the listener. Now the velocity of the listener is how much? CL. Okay, along the same direction. Everywhere I put the arrow over here. Okay, along same direction as that of the source. So that of the source, medium and the sound. So the effective velocity of the sound, effective velocity of the sound with respect to listener. Now we'll talk about listener. Will be how much? C plus Cm minus Cl. Effective velocity of the sound, correct? Effective velocity, like here I did C plus Cm, C plus Cm by N, we know that. And what is Cs by N, that also we know. Same thing I am trying to do over here, C plus Cm by N and Cl by N, because Cs is the velocity with which source is moving, Cl is the velocity with which listener is moving. Okay, and this is same. So C plus Cm by C plus Cm minus Cl is the effective velocity of sound. Now what will I say? I'll use the word N dash, like I use the word lambda dash. Earlier I had frequency N, wavelength lambda, so I wrote C is equal to N lambda. Now with the derivation I had derived lambda dash, which was C plus Cm minus Cs upon N. Okay, now I am defining N dash. Now what is N dash? N dash is the frequency of sound waves heard by the listener. Listener is L. Okay, so that is defined as what? Velocity of sound with respect to listener divided by distance traveled by sound in time. We always use the word in time, 1 by n second. Okay, so what is velocity of sound with respect to listener? We wrote this expression just now. So C plus Cm minus Cl divided by lambda dash, because what is lambda dash? I just mentioned over here. Okay, now substitute the value of lambda dash from equation number 2. So what will I write over here? C plus Cm minus Cl divided by lambda dash. So I'll put this value over here, C plus Cm minus Cs into N. This N will go up. Okay, so this is my equation number 3. Correct? So I got the expression for N dash. I'll write it again over here and say the expression for N dash will be C plus Cm minus Cl divided by C plus Cm minus Cs into N. So this is the expression what I got for N dash and N. This is equation number 4. Okay, or same 3, because nothing be changed over here. Fine. So here what can I say? This N dash is the frequency of the sound heard by the listener. I'll write over here, frequency of sound heard by the listener, because till now here we did not speak about the listener at all. Okay, now next, now this N dash basically is my apparent or the observed frequency. This term is very important. This is my apparent or observed frequency. So again we'll go to definition. Doppler effect is what? Is shift in the apparent or observed frequency and not a shift in actual frequency at which source vibrates. Fine. So now we'll see different cases, what happens in different cases for the expression or the n dash and n, because n dash is the apparent frequency and n is your actual frequency. Okay, so different cases. I'll say case number 1. Case number 1, here what happens, medium, will say let the medium is stationary, okay, and source and listener are moving. Okay, so we'll show that with the diagram. What we want to say, this is my C, the same diagram, this is the source, this is S, velocity will be Cs, this is the listener, velocity is Cl, fine, and this is as usual C. Now what we said, medium is stationary, so I did not write or draw the M, Cm is not there, but the source and listener are moving along the same direction. Okay, now as medium is stationary, what is the first thing we should do? We should write Cm is equal to 0. Moment I say this stationary, Cm is 0. So my equation number 3 will become what? N dash is equal to C minus Cl, because Cm is 0. C minus Cl upon C minus Cs, because again Cm is 0, into N. This is the case number 1. Okay, N dash is equal to C minus Cl upon C minus Cs into N. Okay, so this is my expression number 4. Now the case number 2. Case number 2 is what? Source is moving towards the stationary listener. Okay, so we'll have to be very clear what we are talking. So here source is moving, so you definitely draw the C. Okay, show the source S, velocity should be Cs, moving towards listener, definitely arrow should be over here, and this is my listener, and listener, okay, is not moving, so I can say my Cl is 0. Fine. So in this case I'll have to again go to the expression. So now what I had to do, I had to, in this expression, medium also 0 and this is also 0. So what will equation number 3 will become? 3 will become N dash is equal to, equation number 3, N dash is equal to C M0, Cm0, Cl0 divided by C minus Cs into N. So simple. What we said, the source is moving towards a stationary listener. Listener is not moving with any velocity. Stationary listener. So Cl is 0. Already I said Cm is 0 for this case also, for this case also. So N dash is equal to C upon C minus Cs into N. This is the expression what I got. Okay. From this expression what we get, what we say, that N dash is greater than N. N dash is apparent frequency. So what we say, that when the source of sound waves, okay, source of sound waves moves towards the stationary listener, the apparent frequency heard by the listener is increased. Apparent frequency N dash is increased than the natural frequency or the original frequency. Yeah. Now we'll go to case number 3. What is case number 3? Listener is moving away from the stationary source. Very important. Now in this case what I'm saying, source is stationary. Okay. So basically I'll say Cs is 0. Cs is 0 because a stationary source, and listener is moving with velocity Cl away from the stationary source. So what diagram I should be drawing over here? I'll definitely draw first C. This is my source, has to be there, but this is not moving, so Cs will be 0. Okay, listener is there, but listener is going where? Away from the source. So this is my listener, this is his velocity. Okay, so what is the expression I'll write from equation number 3? I'll write N dash is equal to C minus Cl, M is 0, C minus Cl divided by C, because here M is 0, CS is 0, into N. So N dash is equal to C minus CL upon C into N. So in this case, my N dash is less than N, which is apparent frequency is less than the original frequency. So what we can say, when the listener moves away from the stationary source, the apparent frequency of the sound heard by the listener is decreased. Okay, that's what is the logic. Then the fourth case. What is happening in the fourth case now? Source is moving away from the stationary listener. Very interesting. So here I'll draw first C. Source is moving away. So source has to be over here. Moving away means arrow is towards here. Listener is where? Listener is here. But listener is stationary. So CL is 0. Fine. So whatever I say first, from that we should have a diagram first. So what I said, source is moving away. So S is moving in this direction. Okay, away from the stationary listener. So the first job in the expression will be what? N dash is equal to CL is 0. CM already 0. So C divided by C plus CS. Okay. So here, because the direction has changed. Okay. So what will I say? N dash is equal to C divided by CM 0, CL 0. And down I have C minus of minus CS into N gives you C divided by C plus CS into N. Because direction is on in this side, so definitely I'll have to write the minus CS. Okay, so this is minus sign, so minus minus plus. Fine. So here I can say N dash is less than N. Okay, means what? When the source is moving away from the stationary listener, the apparent frequency of the sound heard by the listener is decreased. N dash is less than N, means N is more. Okay. Now case number 5. Case number 5 says what? Listener is moving towards the stationary source. Source is there, stationary, but listener is moving towards the stationary source. That is the diagram. Okay. So diagram will be, this is my C. This is the source. Source is not moving, stationary source, but listener is moving. So this L towards this. The arrow I have changed. Okay. So this is my CM. Okay. Now to do this, what I'll have to write? I'll have to write the expression now. So what will I say? CS is 0. So take your original expression and try to put the values. So here I'll say N dash is equal to C. Okay. CM is 0. As I said, direction is minus. So minus of minus CL divided by C into N. So N dash will be C plus CL divided by C into N. So which obviously means N dash greater than N. Now here what is happening? The listener, what diagram I drew over here, the listener moves towards the stationary source. The apparent frequency of sound heard by the listener is increased. Okay. Now the case number 6. Case number 6 is what? The sound, the source and listener are moving towards each other. Both are moving. That's a very good thing. So I can say here first, see, this was my source, this was my listener. Now they are moving towards each other. So this person, source will go here, listener will come here. So I'll say this is my CS, this is my CL. Okay. So what I'll have to write in, take the expression into account, N dash. So N dash will be C minus of minus CL, because this direction has changed. Okay. Divided by C minus CS as it is, because this arrow has not changed. Okay, so this gives me N dash is equal to C plus CL upon C minus CS into N, which implies N dash greater than N. Now what happened over here? When the source and listener move towards each other, the apparent frequency N dash of the sound heard by the listener is increased, N dash greater than N. Okay. Then the case number 7. The source and listener are moving away from each other, exactly opposite of this. Okay, moving away from each other. So this is my C, obviously, don't forget that. This is my source, this is my listener. So both away from each other means this arrow is here as usual, but this arrow had changed. Okay, so this is my CS, this is my CA. So in this case, what should happen with this equation? The sign for CS will change. So I'll say expression number 3 becomes N dash is equal to C minus CL as it is, because this direction I have not changed, divided by C minus of minus CS will become C plus CS, because arrow is towards this side, into N. Okay, so in this case I can say N dash is less than N, which means when the source and listener move away from each other, the apparent frequency of the sound heard by the listener is decreased. Okay, these are the different cases what we have seen over here. So what we can say, the motion of the listener affects only C minus CL, and the velocity of sound wave relative to the, that is related to the listener. Okay, and the motion of the source affects, okay, only lambda dash, that is the wavelength of the waves reaching the listener. Okay, now we'll go to the next topic in the next lecture. So here in the first job we have seen total 7 cases as far as taking medium with the stationary and depending on the motion of the source and listener either in the same direction or upper direction and so on. So all 7 cases are very, very interesting as far as what we are trying to listen. Okay, in the next lecture we'll try and cover 2 more topics of the Doppler effect itself. The Doppler effect as such is very interesting, only you should understand the meaning of apparent frequency or the observed frequency, which itself is a definition of a Doppler effect. Shift in apparent frequency is basically Doppler effect and not a shift in the actual frequency. Okay, go through it. Any difficulty, feel free to ask. Okay, thank you very much.